All right, good time of day, everyone, and welcome to this new MLIR meeting. Today, we don't have a presentation, but we're going to discuss the current space of visualization technology in MLIR, the kind of projects that are ongoing or to come, and the opportunities for anyone interested. Jacques will lead the discussion, and Jacques, take it away.
Thanks, Benny. Yeah, no, I think actually like the visualization is quite interesting. I would mention it's probably our most popular open, listed open projects on the webpage, and I think a good reason for it is there is so many different aspects to visualization, and part of me also is like visualization is fun. I mean, like one of the first things I did when I was working on XLA was a graph vista emitter on MLIR, like the same thing. So it's I think for a lot of folks, being able to visualize, and here visualization means different things, what they're working on is very important. And so I think at the moment that there's been potentially like 4 or 5 different visualization projects, somewhat related and on specific areas. I would probably start with even like something like syntax highlighting is a visual aid to understanding the code, being able to differentiate between comments, instructions, things like this. You have like the Graphis one that Matthias did a lot of good work on in terms of representing operations and representing, like, for example, use dev chains. And use dev chains is like one of those visualizations. I think one of the things that's interesting and why it's such an interesting topic for MLIR is the structure of MLIR is very generic. So a visualization, there's no one visualization. If you, for example, think about things like we're doing for TensorFlow or TF Lite graphs, you have a data flow graph, you have control dependencies. It's the visualization that 3 or 4 different people came up with are very similar in what they do because the structure is very fixed. While in MLIR, if you think about like the in-order program semantics of regions and stuff like this, it is not as trivial. So I mentioned about things like showing the use depth relationships. Folks have also shown some interest, but we haven't not a lot of work there yet in being able to explore the IR. So basically meaning, going into a block, being able to expand it, contract it, being more dynamic in terms of your querying and your visualization of areas. Freyam and others have also talked about like visualizing patterns and from 2 different directions. One more in the context of almost, if you can think about it, like a dictionary of rewrites. And for myself, for example, I love seeing a rewrite pattern actually as the DAG being matched. And then we also have cases where you think about like it from a debugging point of view, visualizing to see the changes being made from step to step going on. And then we had Scott also showing visualization with respect to number of operations and things changing of composition of a model during the optimization pipeline. And so I think that's another interesting visualization. And I'm blanking on the name now. Some visualization queries in terms of like memory usage, for example, over time for a given graph, for a given schedule is also interesting. So, if you think about, I think that this is a very interesting space because there's so many different, visualizations that is possible. At the moment, what we have is more like on the syntax highlighting side, more on the just instructions as a graph with a node representing operation and data dependencies representing edges. And then with a couple of things in flight, but not very concrete yet. So sort of with that little bit of rambling introduction to like some of the different things going on, I'll hand it over to Freyam, who's been looking at a couple of these things as well. So to just answer Max's question, so syntax highlighting, yes. So we have highlighting for VS Code, for Vim, for Emacs, for TextMate. All of them are in the LVM repo for actually and GitHub. We have GitHub syntax highlighting as well, and Hugo syntax highlighting, and Highlight.js syntax highlighting. The the first 4 or 5 are in the MLIR repo, with VS Code being exported to a read-only packaged repo. Highlight.js is in the Highlight.js organizations subfolder. And which one am I missing? The Hugo one. Oh, that's in the, I think, Chromatic. We made that contribution there, but I forgot now. Freya.
Right. So hi everyone. I'm Freya Mehta, and I'm actually currently a student from Triple IT, which is in India. And so basically, I would like to share my screen, and then we can get started. Just give me 1 second. Yeah. So present to the meeting. Right. This should work. Are you able to see my share? Yeah, you can see it, right? Okay, good. I'll go on. Okay, right. It's quite like a short one, but yeah, like let's go. Okay, so right. So basically, like what I'm trying to propose here is that like we could be like, I mean, yeah, so basically like we actually could use Graphis to actually show two different pattern matches. I mean, so like we could actually like show the entire process of rewriting, which basically has two parts. The first part being the pattern matching, and the second thing being the pattern rewriting. So like there are really two parts here. So right. So what's the overview here? So I think around 1 month back or something. Oh wait, I actually can't share double tabs. Just give me 1 second. Wait. Sorry. Where's the meet? Right. Yeah, I'll share the entire window. That's better. Yeah, okay, cool, right, okay. So basically, right, the overview would be like, so on September 12th, I actually came forward, I mean, I just came across this thing on the Open Projects Fella page, and it actually seems very fun because recently, around 3 months back, I was working with an org called Dask, and I was working on something very similar. So basically, even Dask has a thing called Dask rewrite rules, where basically you actually like could change these syntax algorithms for every specific like tree. And in this I mean, when it comes to Dask, tree would mean a task graph. So similarly here, so basically here, what I have done is I've created like this graphis kind of thing. For example, you can see here, right? So you have this, you have a very simple code here, and the simple code is mapped to this task graph, where all the nodes either represent the variable or the function or the module that is being used. Right. So similarly, what we can do at MLIR is that. Right. So yeah, so like okay, yeah, so right, and here I actually went through this video of yours, which is on. Yep. Yeah. So I went through the video of yours, and here he's talking about the fact that there are these DAG patterns where basically like you have an input DAG and then you actually pass it through through a transformator or something, and then like you actually get an output DAG which actually might have some of the nodes removed or something, because I guess some of the optimizations happen and all. So like yeah, so right, so like that's where I got the idea from. So basically, what we could do here is that even we could like start using Graphis, right? So okay, yeah, so I'll just give you a simple example to get started with. Okay, so you have a very simple function. It just adds to x plus y, and that's it. So this would be the DAG for it, and this is post optimization. I actually don't remember the name of the transformer which was used for this, but yeah, right. So basically, this is after the optimization. It is quite simple. So basically, instead of having two different variables x and y, you can just straight away pass that to the this function call itself, and you would get this. Right. So now you have two different graphs. So one is the pre-optimization, one the others post-optimization. So now what I mean, it's actually like super simple, like the thing that I have shown here. But like we actually could like go a step further, and even show for like n number of like difference. For example, you have an input graph. I mean, you have an input DAG. You give it to a transformer. It comes out. Some of the nodes are gone. then you again pass that to a different set of, so yeah, so you basically have like an entire set of transformers where basically like it keeps getting optimized every time. And basically one thing what we can do here is that basically we can have like a slider form. So basically at every interval of the slider you will see the input and the output for every transformer it goes in. So now this thing is quite possible in Graphis, because Graphis does actually allow like n number of whatever. It can be like how many number of graphs you want, right? So now for this thing I actually can like think about like for example, I mean it's okay, since this is going to be very hard to do all this, but it's still possible. So basically that, and yeah, the actual hard part for me here is that I'm actually fairly new to MLR itself. So and plus like I'm actually a student right now, so I actually don't really understand MLR and its use cases a lot at the point. But right, so like I would like to learn that more from all of you. Like I would like to like learn what is actually important to you guys, and like for example, yeah, I have some classes for that. Yeah, it's a very short presentation, but right, yeah. So like, yeah, like what I would like to like learn from the entire community here is that like what tools can be used. I think like Graphics is a very straightforward tool. It's quite popular, and I do have experience in it as well. Like useful information. For example, I mean, at least for now, I have thought of pattern matches and all that, and how do we show it graphically? We could use where is it? Right. So we could obviously just use a simple red becoming green or something like that. Or there's actually one more thing that I actually just came up with recently. So basically, I have like a got it out yet. I'm sorry for that. But yeah, so basically, what we could do is that, right, okay, we take the same example, right? We take the same example. And now, okay, we see that this constant 0 and constant 2 is getting mapped to just a single, to just a single constant 2, right? Yeah. So now, what we could do is that we could just create a subgraph. So basically like you will have the entire pre-optimization graph and the entire post-optimization graph like side to side, and we will have a smaller version of both the graphs just below it, right? And in the smaller version we could just like draw a box. So like basically a box around one. So like constant 0 from the pre, constant 2 from the pre, RD from the pre, and this entire thing would be mapped. So like I guess so now since it's part of the same box, so it kind of shows that okay, now this thing used to be this and now it became this, but it's the same thing. So like maybe like some kind of like box we could draw around it. So basically what I'm trying to say is that so yeah, so there's going to be a box starting from here, and then like just like that. Yeah, and that's kind of it for the presentation. Didn't have much to offer. I would like to like learn more actually from you guys today, and maybe by next week or something I could come up with a more concrete graph. I mean a concrete presentation with more ideas to like flowing and all stuff like that. Yeah, that's kind of it.
So I have perhaps a question like, how do you see this scaling when the graphs get bigger? You know, so when you have a couple of small nodes, it is relatively simple to capture them all together.
Visualize that, right? That is true.
Yeah.
Okay, for example, if we have a graph of me, just for saying 100 nodes or maybe 500 nodes, now Graphis actually would export a PNG or an SVG of around 1000 pixels by 1000 pixels. So like it's going to be a square. So right, so basically now what we could do is that every node would be like scaled down. So every node would be scaled down, and like people normally would not be then able to see what the node actually contains, or like what the node is actually like named after. But like the colors would still, I guess, like make more sense, because like color is something that the human eye can distinguish very easily, and especially if you go for red and green. So like even if you have like there is small red, and then this is becoming green in the future, at the same position, because we are showing the pre-optimization and the post at the same time. It's not like, so you first show pre-optimization and then the post. It's not that. It's at the same time, like right next to each other. So I guess the color would play like a very big role here.
Gotcha. So, I mean, so in the sliding one, I mean, even if we were to show this like one after the other, I mean, wouldn't the colors give you like the same idea? Because you would at least see, well, your point is like we want to be able to visualize also the things that get removed, not just the parts that gets changed, right?
Everything, yeah, it has to be everything. I mean, what I have actually shown is like a very preliminary analysis of all this, but like, yeah, I like once we dive into like more examples, I guess I'll get like a much better idea of what could be done, right?
Yeah. So, I mean, I think one thing that could be difficult here is the actual mapping, because you can have, for example, let's do like I don't know, like something like CSE or whatnot, which could actually have an effect of, let's say you have 50 constants all of the same value that gets deduped into one,
Okay.
but they're all over the graph and they get hoisted out into the top region. I mean, so if you do like the boxes one, I think it could get quite. But yeah, I'm wondering, like it seems like it could be quite
That
difficult
is
to actually
true.
attribute,
That's
exactly
true.
what it's
That's
going to
true.
draw.
Yeah, that's true actually. Like it wouldn't look very good first of all, and plus like it's gonna be like so small, and like people will be like, okay, wait, so is that just a dot or something? Like what's that? Yeah, that's gonna be true, right? So like for the large number of nodes plus, like when sometimes your nodes are like very like long on maybe like the top or the like or the bottom end, and the middle you have only like two or five nodes. It's that imbalance, yeah, that imbalance might look very ugly, I guess, on the screen. That's true. That's true. So like
Yeah.
I guess for that we could think about like some kind of way to like format the graph, where basically it kind of like auto arranges the nodes, because I think like Graphics by default does not export like in an auto spaced way, but like there seems to be some way that we can employ that as well in Graphics.
Yeah, I think I don't know if it was Dagger or one of those, which actually allowed you to track a node across different views. Because like one of the things that if you run it on a new graph, your layout could look completely different. So even if you're making a local change, for example, you're taking these nodes and you're just collapsing them, your output graph could be completely differently laid out, so the correlation is bad. So
Exactly, like
yeah, so,
the
so that might be
the
interesting. But
relative presence has to be the same. Yeah,
yeah,
the
which actually
relative
brings
is
up another topic, and that is sort of we have the LLVM MLR canonicalizer canon whatever tool, which was the intention was to reduce the visual diffs. So if you look at that tool, so LLVM canon basically it attempts to do some renaming and some movements so that if you were to do like use like a textual diff of before and after, it would expose more the actual differences
oh
versus
wow.
things due to renaming. So that actually might also be interesting here, because then this is something where it could give you, it in a way puts it in a format where a diff shows, more actually important changes happening versus just, hey, we renamed some things and now every single line of code is different. Because why
Yeah,
not? Like we reorder to instructions. So that, if you're looking at this, I mean, that might actually be an interesting thing to look at as well, because
that is
that at
true.
least gives you a good starting point for the next. Um, but yeah, like I think that the structure part, keeping the structure would be really interesting, because if you lose the structure from like one step to the next, visually it becomes really difficult to correlate what happened.
That's true. That's true. Like that is gonna be exceptionally hard, I guess. Like maintain like across, because see, for example, the same graph which might start with 100 nodes might like become around like 6 to 7 nodes by the end. And yeah, exactly. So that we need to take care of. So basically that has to be mapped somehow in one-to-one ratio kind of thing. It has to maintain throughout every single transformation, basically from 0 to 1, 1 to 2, and then till the end. It should look that okay, that so see, I guess our entire goal would be that if somebody is if somebody is looking at the final graphs, that person should know that okay, that this part of the graph came from this thing came from this, and this should be quite easy. It shouldn't be very hard to decipher or something.
So I would make it slightly lower requirements. So at least the before and after of a transform should have the same structure, but I think it would be difficult. As basically, my one concern would be if we try and keep the same structure throughout, you may end up with a very bad visualization at the end, which made sense for the big one at the start, and so you're sort of losing visual info and ability to differentiate as you go further. So I mean, for example, we're doing function outlining, but we still keep this big gap open for the ops that were converted into a function call. Now all your next transformations get harder to actually identify what changed for them. So yeah, I mean, I think it's definitely very interesting. I think it's not a trivial one.
It's hard, right? But yeah, I would love to work on this. So
Can I?
Right.
Stephen?
I was going to bring up another concern that I have, which is that a lot of times we actually start with a really big design, and you're making that there might be lots of places where a rewrite rule has a change, and the challenge might be actually finding the one place that you care about. And so in addition to kind of navigating forward and backwards through a sequence of transformations, even just navigating within a big design might be part of the challenge. And I was wondering if you have ideas for how to do that in a nice way in GraphViz.
So would this be a case where you have a flat design, a low number of ops, and you want to be able to zoom into a section, or?
Well, you might have a large flat design, or you might have a design that's very hierarchical that has SCF ops in it, and you need to you want to traverse the hierarchy. And sometimes that hierarchy is sort of, I would say, simple, like traversing from outside an SCF if into an SCF if. But in other cases, the navigation that you might want, like you were talking about with function inlining, the navigation that you might need might be across to a symbol, or between different basic blocks or between different regions, if there's something that an operation keeps a correspondence of, right? And so, I think it's probably worthwhile, even just thinking about how to have, instead, maybe even before you get to visualizing a transformation, visualizing how do I navigate a big design, which I think the textual highlighting things don't really quite address. Maybe you get a little bit of it if you can take a region and you can collapse a region. But maybe something to think about and brainstorm a little bit on.
Yeah, I think that's very interesting. So in a way, I think there will be a feedback with the LSP here as well. Which makes me wonder, because the LSP at least gives you the ability to navigate up and down. I mean, one of the downsides to GraphViz is it's not that interactive.
It's a static output.
Right.
Yeah. So, which of course, could be handled by actually doing a feedback loop and just regenerating a new static graph every time you click a button. So it's not impossible, but I'm not going to say that's going to be fast, but it's feasible. But yeah, I mean, I think it's a good question, because another thing when you were talking about is I was thinking about one other part which sort of matches to this one, where it's if for a given op we were able to track it down and say, okay, basically, hey, just give me this area of this op, and on the slider, show me where it changes or its area changes. Because in a large design, to have to find the same op every time is going to be a pain. Yeah. But you have a good question. Like on the navigation side, the visual navigation side, how you walk in, expanding regions, collapsing them again. My mind went to like folds in Emacs and Vim and all those kinds of things.
But you might actually want something different from a pure visualization and navigation tool that's different from like an editor, I guess is what I'm thinking. There might be some things that are similar, but some things that are different.
I actually have something for that. I'll just show you. Wait one sec.
Oh, cool.
So this is something I am also working for Circ. So it is also quite similar. Like I guess I'm doing something similar everywhere. So right. So this is something that is basically yeah. So in this every rewrite pattern basically matches a quantum circuit. So I think like this is something that even like I had in mind for MLIR as well. So basically we'll have a slider where basically like it kind of shows the input. For example, the left side is the input and the right has to be the output, and like maybe we could just like have a slider go from like the leftmost to the end, something like this. Like is this something you have in mind? Something like this.
Yeah, kind of. I mean, this is still a very small example,
It's
right?
small. It's
So
small.
you
Right?
can
I mean,
sort of take the
in
whole
MLIR we have
design
graphs. We'll
and
have
fit
big
it in one
graphs.
graph, right?
Yeah, I think it's very interesting because, for example, like I'm a big fan of Graphs, but once you get to a couple of 100 to 1,000 or more nodes,
It's slow. First of all, it's super slow, and at the same time, it actually like won't show much. So we should actually like okay. So there's actually one more thing called GraphViz DD3JS something. I forgot the name of it. I think it was GraphViz system only, I think. Right, this one. So this is actually quite good. So basically, in this, you actually like can zoom into stuff and all because like the normal graphics will just like not allow that. Wait, it wasn't this. Like I remember that there was this one very, for example, yes, even at Dask, I actually like made like an entire list of alternatives that could be like thought of like I mean like which could be used in place of graphics because graphics is obviously very fast. It's very good, but it has its own limitations which can be easily fixed by some others. There's also a thing called network X which we could use, right? This is also something which we could use for us. I mean for our thing which really works very well with large graphs. Like for example, if you have 1,000 nodes and all, it's very good.
Oh, sorry. Go ahead.
This is a funny coincidence. I was yesterday just fiddling with GraphViz, and so this is not directly related to this discussion, but I wonder if anybody has the answer to this question because there are apparently several people on here that are familiar with GraphViz. It seems like a pretty weird markup language syntax, whatever you want to call it. In particular, I was trying to parse the table. So I was going to actually say something like, oh, I don't have a lot of sophisticated opinions in this space about visualization for MLIR, but I would advise against GraphViz because of this table thing that I was running into yesterday, but maybe you guys know and love GraphViz and you have a way around this. I don't understand how to parse the tables, right? So there are all these libraries in Python that you can use to parse GraphViz files, dot files, and it'll give you the graph representation, and you get an edge list, node list, whatever. But the labels, sorry, I should say labels. The labels, if they're not HTML labels and you can't use something like Beautiful Soup, they have this weird like pipes, braces, you have to escape angle brackets thing. And all of the parsers that you can grab in Python just give you that as a string, like not parsed. So the question is, how do I parse the label that is a table? So they have this struct representation or record representation.
So basically HTML tags, graphics. Right. I actually worked with this as well. Yeah. So we have this thing called this. I believe you're talking about this, right? You're talking about this.
Yeah. So I wish I were talking about that. You can encode the labels as HTML tables, but the thing that I'm getting this graph from uses braces pipes. So you can if you've not seen this, then maybe you probably might not have the answer, but yeah. So there's this other way to encode the labels. Sorry, somebody's going to say something.
No, I mean, you're correct. So I think if you look on the Graphviz website, it's the example with like the ports one where you have, and it's used for structures often,
Yes.
where you have like a top level and you have different ports on it.
Yeah. So the annoying thing is that I'm getting Graphviz actually from like CUDA. So CUDA has a thing that you can use to dump their Graphviz, a Graphviz representation of CUDA graphs, and they have mangled C names, right? Like CABI mangled names, and if you demangle them, you get angle brackets, and those have to be escaped, and all these crazy things happen, and so I have to parse the label, find the mangled name. Anyway, so the question was, yeah, does anybody know how to parse those struct record labels? No, the answer is no. That's fine. Shot in the dark. Hope, like, fingers crossed. Yes, it's
yeah. Okay. So no, I mean, I've seen. I was trying to find one of the examples from. Oh, I think this data structures example showed it. Yeah, that's the one. So no, that's actually. I think that's a purely like this. So mostly what we've been going through is like one way, but it's actually a good point where if you're consuming this, you want to do something more with the output of Graphviz. It's sort of it's a little bit more difficult because of you pretty much have to implement your own parser for this. That's actually a good question. I don't know if there's anyone for it. I've never actually had to do it.
So the weird thing is that there are a bunch of libraries, and even the best one in Python. So whatever, I'm stringing all this together using Python. There might be something in another language that's more effective, but the canonical Python one is bound to the C library, right? It's just like a thin supposedly wrap around the C library, and that engine, the Graphviz engine, apparently only gives you the label as a string, not as a object, which is weird. Because I'm sure that there's a parser inside somewhere of Graphviz for those tables.
Yeah, that's actually a good question. I've mostly been on the end generating these things, not consuming them beyond GraphDiff. So.
Yeah. Anyway, thank you.
Oh yeah. So hi everyone. So going back to the question of large graphs. I mean, I love Graphviz. I love how Graphviz and Dot can display graphs really nicely, but it does struggle against very large graphs. Like one time I tried displaying PointNet, and my computer was running overnight and never finished. So what we've had to resort to, because we're working on software, and it'll try to go through an Onyx model, and if it finds a potential problem, say like with one of its nodes, we would like to let users know, hey, you might have a problem with this node. But how do you do such a thing with a very large graph like PointNet? I mean, I don't know. I wish I could display the whole graph so users can say, oh yeah, maybe this part of our model is where things are going wrong. But what I had to resort to was instead try to provide a context. So it's a very naive approach. You identify the node that's a problem, then you traverse up and down the graph to certain points, and then you can output, say, like a dot file and SVGs. And with the tooltips and alerts, you can provide more information about the node, and hopefully that provides enough context for the problematic node. But I wish there was a way to dynamically load parts of the graph in like dot Graphviz or even D3. I don't know. Do you guys know of any tools that can really display large graphs really well? Like I tried NetworkX, and I'm sure it works great for smaller graphs, but when we tried a very large graph, or even like ResNet 50, that even when applying constraints to like I think the spring force method, how many nodes or edges? Geez, I don't really know. But I mean, for even something like ResNet 50, it's not that much. Graphviz works really well with that. NetworkX, not so much, but we try to make it generic. For PointNet, I don't know for sure. I'll have to load it up and let you know, but it's very, very large. I mean, probably way greater than 1,000.
So I mean, I can mention what TensorBoard does here. So TensorBoard, in its graph visualization, it tries to basically lump things together as much as it can, so that like the big graph, it tries to sort of create like different scopes for them. and you have to dig down to actually get to the data. So you have this process of sort of like exploring the graph and expanding as you go. That works well for, I think, folks that want to see the structure and dig in. It tries to be too smart for me because I really care about every single edge. It tries to remove edges that aren't actually interesting, versus normally those edges are interesting for me. So that's sort of like the other one where it tries to effectively create like a hierarchical representation, which you can dig into dynamically. But yeah, I mean, your point about like visualizing a region, that's the one I was trying to look for. Thanks, Scott. So Gephi is another one. Gephi is actually really nice for it. It's what it visualizes is not always the most. Its output is not the most intuitive to folks. But I found for large graph, that's the only one that actually gives me anything useful. But again, it's very different than what people are used to normally seeing if they look at the Gephi graph.
Mm-hmm.
I think Scott, sorry, yeah.
Sorry, yeah, I ran into Gephi as well, but I was also looking for something that we can easily modify. So say like before we were saying like change the color of nodes, or we want to add additional information. Is that possible in Gephi? Like we want to click on a node and something will display saying what went wrong.
So I think the Gephi one, at least the way I've seen it used is it's Java based. It is there's nothing. It's not interactive from that point of view. So mostly you can set some rules to color nodes in different ways. I don't actually even know if it has a pure command line interface. Probably does. But it goes through like a bigger placement and layout step before it generates the graph. But it scales pretty well. So I think that's one of the ones that. But I think the downside is the output it produces. It takes a little bit of getting used to, and it's it's not. I don't think you have the same amount of customization. I don't know. I might be wrong. Same amount of customization that you do have with GraphViz for different sections. But then, Scott, you probably know a bit more about this.
Yeah, I would use Gephi for something like seeing which parts of an overall program graph are more isolated from others. It really gives you that connectivity and structure. Actually looking at a node and seeing like, what is this defined from? What are its properties? Like, I wouldn't really use Gephi for that. This discussion did give me some other ideas about more artistic visualizations. Doing something like throwing the program into Gephi for each phase of compilation and then stacking those renders into a video. Gephi does let you do nice things with coloring and styling.
That's quite good.
Pretty pictures.
Yeah, that's actually really fun. I mean, I somehow wonder if we should have like a directory of visualizations. Well, some scratch for playing around with some of these, because like it seems like a nice brainstorming actually. Yeah, because even like if you did Gephi for the regions, and if you had some way, I mean, Gephi will produce an SVG or something, connecting the SVG nodes up to JavaScript actions, which then on trigger would, launch a D3 GraphViz visualization of a smaller section. Would be interesting. I mean, of course, now we're combining multiple tools, which would not be readily on everybody's desktop. So there's a downside to that.
Yeah, the tools you were using already, the GraphViz are nice in that they're kind of utilitarian and accessible. Gephi's ancient software, Java-based, difficult to plug into C++ and Python and integrate natively with web tools and all that stuff. One of the trickier things with this is just getting your data into a good format. So writing the C++ MLIR passes or whatever to spit out something in a graph format that may be many, many megabytes or gigabytes in size, and then figuring out how to load that into a library. It's definitely easier when you're looking at small models and things like run a canonicalization pass on some constrained input, because then your input is pretty small. But as soon as you start to look at the middle of a giant program, then you start to need to slice out parts of that program, narrow down your input output sizes.
Yeah, and so Craig, when you're doing the slicing for like the error representation there, how do you do that? I mean, like, do you slap in like placeholder nodes or whatever to sort of say like, here's the region beyond this, here's some inputs coming in, but we're not going to show you those, or how do you represent that to the user?
Yeah, so I first walked through, so we started with an Onyx model, and I walked through the Onyx graph, and I do have my own custom subclasses of, I think, pi.node and pi.graph, so we can have more information about its inputs and outputs, because those aren't usually readily available. And even through Onyx, it's like, sorry, I digress a little bit, but Onyx gets a little weird, right? Like we, for a particular node, it doesn't matter what its name is. What matters is its inputs and its outputs. But its outputs is basically what the node is actually computing, right? So I tie like all those outputs to the same node. But anyway, so what I do is, yeah, I do have to keep track of all the nodes and its inputs and outputs. And then when I find a particular node I want to focus on, I traverse the graph up and down again. And I say, hey, you have just a particular limit, because there's a possible chance that you might have a very large graph. You don't want to keep going forever, right? You just want to provide a context for something like this. At least that's what we wanted to do. And whenever I reach a node that has multiple inputs or outputs, I consider that an end node. And then I just hope right then and there that's enough for the context. And hopefully the user might know where in the model such a node might occur. So it's pretty naive, but
So, is the tool or project you're working on, is it open source? Sorry, I don't actually know the affiliation.
Oh, the code I have is not open source yet.
All right.
But I mean, you're just traversing through a graph, and if you identify a node that's multiple inputs and outputs, I thought that would be good enough to consider as an end node, and then that will be your context. And then you could ship it off to Graphviz to do the layout. But like I said, it is really naive, but it's what I could come up with in a short time.
I mean, I think on my local machine, I have this like crappy script where I generate Graphviz for the Graphviz file, loaded via Python, traverse 4 or 5 layers up, and print it. So I mean, it's like, I think that is very practical. So I think it gives a nice context. Okay, so you do this per error case. So this is a case where the user has run a model on failure. You do this.
Yeah.
Okay.
And yeah, because like traversing through the graph and keeping track of all the edges is actually it doesn't require much computation power or memory, I guess. It's when you run Graphviz and try to calculate the layout, that's where all the hard work comes in. And so we had to find a way to reduce the work for Graphviz.
Sounds good.
Hey, so I used to work next to a research group that did a large graph visualization. There was a guy there who always used to have a great rule of thumb when it came to scaling up visualizations, and that's take the number of pixels in a typical monitor, right? So it's like 1900 by 1200, whatever. That's a couple million pixels. Take the square root of that, or sorry, divide by the number of nodes you're talking about in the graph, and then take the square root of that, and that gives you the approximate pixel by pixel size of the largest thing you can possibly fit on the monitor to see. And if you do that with a 1,000 node graph on a typical monitor, it's like 40 or 50 pixels. So when you're talking about large graphs of that order, you should start thinking like the largest thing you can display is like the icon of an app. So the amount of information you can actually get there is basically none. Which is of course why they spent most of their time on like graph coarsening and subgraph visualization, as opposed to trying to look at something very, very large. But I always thought that was a really useful way of thinking about things, to just say, okay, here's the upper limit on what you can actually visualize. And if it's any larger than that, you really need to take a different approach.
Nice. Perhaps sort of like more in general as well. Is there, what other visualization needs or things that we haven't mentioned have folks run into where it's like, we actually need X, or not need, but it would be nice if we had Y kind of category?
One thing that might be useful is actually just visualizing the chain of passes that would happen, or chain of patterns in a large set of passes. That's more of a kind of a visualization of the structure of the code rather than the structure of a particular piece of MLIR that you're trying to look at.
That's a good idea.
Oh, I don't know if Ben Vanek is on this call, but we had an idea for kind of code coverage analysis, particularly at runtime for dynamic models for programs that have control flow. It'd be nice to be able to annotate which parts of the program, which MLIR functions, etc., were executed, which were the hot paths. You could do similar things at compilation time or at runtime, depending on what you care about then.
Nice. And I like the video idea as well. I actually do want to. I'm curious how that would look like for some of the bigger models, to see how it progresses from like TensorFlow down to Erie, like via MHLO and LinAlg and flow dialect and all of this. I think it would be quite interesting.
Yeah, I would expect a similar kind of expansion and contraction, like the 2D graph that I presented a bit ago. But
yeah,
with the directed graph format, you'd see more really expanding out and narrowing back down. You could do similar coloring by dialect type things at a graph level.
That would be nice. Yeah. I mean, one of my favorite optimization algorithms is like Nelder-Mead, because which the nickname Amoeba, because of like just the nice visual aspects of it, actually like contracting, expanding, and moving over the graph. So I don't know. I just thought about that when you were talking about this.
Yeah, Gephi is a fun program to play around with for that, because you throw your graph in it, and then it gives you a drop down of all the different layout algorithms you can use, and it'll apply them iteratively, so you can see the nodes in the graph kind of wiggle around as they find their own local groups to be associated with. More interesting than running an offline render and then doesn't complete overnight.
Another possibility would be to just visualize the dialects that are in a design, and okay, be able to load a design and quickly go, this is a LinAlg on tensors, without having to look at it, right? Or, oh, wait a minute, this is mostly LinAlg on tensors, but there's a few weird things in there.
Yeah, that's a good. I mean, I like the dialects one. So I mean, for me, it's always interesting to see like the different dialects come into play, and we sort of see a reflection of like what Alex's doc on like the cogen structures. You can almost conceptually, it sort of like feels like we have nodes running through the edges of that graph to the final cogen. For debugging, is there anything that, I mean, we talked about a couple of things here to sort of just visualize, when changes happen. Is there anything else that folks would think would be useful to explore there? So, I mean, I think that a couple of things that have been highlighted here is sort of like the traceability aspect, scalability, visual stability, interactive nature, or potential interactive nature, like how we do that open, and potentially a hierarchy. Coming back to like what Bob also mentioned, the information we can display and the information that may be useful for people debugging change, and Craig as well, changes quite a lot. And if you can expand some of the error domains, that would be useful. Okay. But yeah, I mean, I sort of do want to create like a folder where we can put like artistic renderings, as Scott mentioned, so we can play with, not in the LVM repo, that would be bad. But yeah, I think that would be quite interesting to see what kind of artwork folks can come up with here. Sorry, Craig, I interrupted you.
Oh no, you're fine. Actually, that was a really good discussion. Actually, even like going back to what Bob was talking about, focusing on subgraphs, or what I'm not sure if like is it it's explicitly stated in the model that's a subgraph, or if it's part of like say a control flow / loop, or is there a way to identify to section off parts of a graph automatically that this could be an important subgraph that we can expand or compress?
So what is done in TensorBoard, but it's a little bit TensorFlow specific, is because you have the scopes effectively adding like prefixes to blocks. You can have the name of a block of an operation becomes like linear layer / blah / blah / blah, and sort of what people have written in Python and how they structure their code ends up being somewhat captured in the names. I mean, it could be better, but for example, in TensorBoard, that's used sort of as a heuristic to say like, okay, well, things that have a similar common prefix, even based on slashes, probably belong together in a subgraph.
Right. Yeah, and I guess that gets to the model code level, right? But say what if we didn't have that information? So if for example, if I so I'm mainly a TensorFlow user, but say if we started with Torch and we exported that to Onyx, we lose a lot of information of what module it really came from and whatnot. So it's hard to identify by name, like how to organize the model, right? Or if I start off with Onyx off the bat, I am not sure if there is a way to view it in TensorBoard natively. Is there?
That's a good question. I know TensorBoard added some support for PyTorch, but I don't know exactly what they did. And I think it requires special calls from the PyTorch side to annotate some things, but I've honestly never used it. So, very good question. You know, it may be that it's so saying, hey, we need some convention, or some of these front ends, if they have a shared convention, we can exploit. Yeah. So sorry, Nader, I saw you unmuted. I don't know if you had something you wanted to discuss. No, potentially just an accidental unmute. Okay. Yeah, I mean, thanks everybody. I think this was a very fun discussion. I mean, we can definitely continue it like on the Discord forum, and I mean, my email is easily available if you guys want to contact, or the mailing list, you know. But yeah, I mean, this is a fun topic. Honestly, it's very fun.
It is endless, right? Like when there is the best way to visualize something, and like you can always do better every time.
Yeah. I mean, of course, there's always a risk to having backend developers visualize things. I mean, yeah.
Yep. Yeah.
Is there an action item or someone that could write a summary or something of the discussion? I don't know if it's possible, but otherwise the video will be a good artifact still. It just isn't very dense. Nope. Okay. Well, thanks everyone for joining today. And feel free to propose any discussion. Like, thank you, Freyam, for proposing this discussion today. And see you maybe next week or next time. Bye, everyone.
Hey, everyone.